Hello everyone, let's solve the problem minimize deviation in array. You are given an array nums of n positive integers. You can perform two types of operations on any element of the array any number of times. If the element is even, divide it by 2. If the element is odd, multiply it by 2. The deviation of the array is the maximum difference between any two elements in the array. Return the minimum deviation the array can have after performing some number of operations. Let's see the example. This is our given array and initially we have a maximum difference or maximum deviation. So what is the maximum deviation here? It's the difference between the maximum element and the minimum element. Okay, that is 19. So initially our maximum deviation possible is 19. Our task is to minimize this maximum deviation. Our task is to minimize these maximum deviation. There is a bit improper phrasing in this problem. We are not supposed to return the minimum deviation. We are supposed to return the minimum possible maximum deviation after performing these operations any number of times. All right. Now the thing is, how do we lower the maximum deviation? Say this is our maximum deviation, right? How are we supposed to decrease it? We can only decrease it if we increase the minimum element and if we decrease the maximum element. Then only the gap between them is going to decrease and our deviation is also going to decrease, right? Now we are given two types of operations that we can perform. If an element is odd, we can multiply it by 2. If our element is even, we can divide it by 2. So this thing is given, and this idea of increasing the minimum and decreasing the minimum, we are going to use this idea. Okay, now let's try to apply this operation on the elements of our array. Currently our maximum deviation is 19. Okay, we can increase an odd number by 2, multiply it by 2. What are we going to do? We are going to increase the minimum and decrease the maximum. Okay, so let's increase the minimum. We have 1, let's multiply it by 2, we get 2. And let's decrease our maximum. What is maximum? It's 20. It's even, we can decrease it by 2, it becomes 10. Now what is our maximum deviation? Our maximum deviation is maximum minus minimum, that is 8. Fine. Now let's do it further. Let's increase our minimum element. Our minimum element is 2, but 2 is even and we can't increase a number which is even. We can only divide it, not multiply it, right? So we can't perform any operation on this one. Let's leave it as it is. Now what is the maximum? It's 10. What can we do? 10 is even. We can divide it by 2 and make it 5. Now what is the maximum deviation possible? The maximum is 5 and the minimum is 2. 5 minus 2 is 3. Okay, can we do anything further? Let's see. Our minimum is 2, maximum is 5. 2 is an even number, we can't increase it or multiply it by 2. The maximum is 5, that is odd, we can't divide it by 2 anymore. So this is where we stop. If we try to alter the other elements, let's say we can increase 3 to 6, we can decrease 4 to 2. It's not going to help us, right? Because 6 is a bigger number and 2 is a smaller number. Our deviation increases to 4. So that's not useful, right? So this is where we stop. So let's try to observe something. What did we do? We increased our minimum at each step and we decrease our maximum at each step. That's what I told, right, initially. So what does it mean? We are going to need access to the minimum and maximum at each step, right? We are going to need access to the minimum and maximum at every step, and if we can, then only we can alter it, right? For this purpose we are going to use a tree set, that is an ordered set, right? It will provide us the access to the minimum and the maximum at constant time, right? We are going to need min and max at each step, right? So we are going to use a tree set. Now what will be our algorithm? At first we will initialize our tree set, right? Then in the set we will add the elements from our array. But if an element is even, we will add as it is. But if an element is odd, we will multiply it by 2, double it, and then add it. Now, why are we doing this? See, our first type of task is to turn the odd numbers to even numbers by multiplying it by 2. And the second type of task is to divide the even numbers by 2. Okay. Now, we know how are we going to achieve the minimize the maximum deviation by increasing the minimum and decreasing the maximum. So, by multiplying the odd numbers by 2, we are increasing the minimum possible values in nums which are possible to be increased, right? So if we have 1, if we have 3, we increase them to 2, we increase them to 6, right? We are doing exactly this thing, right? So we, at the very first, we complete this task. Now our task only remains to perform this one, that is minimize the maximum values that are present. And by performing all these operations, we will at each step keep calculating our difference, and one of them would be the minimum. We will keep track of that. Okay, now let's see the code. Initially we are going to have a tree set integer. Let's call it set new tree set. Okay, what are we going to do? We are going to put the elements in nums in the set. If it is odd, n modulus 2, if it is odd, we are going to add its double, set dot add n into 2. Otherwise we are going to add the number as it is if it is even. I have made this part shorter by using a ternary operator. If the number is odd, if it is true, add the double, otherwise add the number itself. Okay, now let's initially have a minimum difference. Let's initialize it with maximum value. Okay, now let's start our work. While true, we will do that as long as we are able to do. Let's see, int min set dot first. This is how we extract the minimum, right? It's the first element in the set, which is minimum. Int max equals to set dot last. The last is going to be placed at the last position because it's sorted. Okay, minimum difference is going to be math dot min minimum difference and the difference between current maximum and minimum. Okay, if our maximum is still an even, what we will do, what did you see, we initially turned all the odds to evens. Now we are trying to divide the even numbers and make them odd. We are trying to minimize the maximums. Okay, if the maximum is an even, let's decrease it. How? We will first remove this element. We'll first remove the max and add its half, max by 2. Say if our maximum is 20, we will add 10. We will remove 20 and add 10. Otherwise, if the maximum element that we are looking at is no more a even number, let's see in this example. See, the maximum element in this case is no more a even number, right? We have an even number here, but if we divide it, we are still getting a 2, right? This is not going to make any difference, right? We are supposed to look at the minimum and the maximum, so we can't change the maximum anymore. In that case, we will break out, and at the end we will return the minimum difference. Now let's try to run it. Fine. Now let's quickly do a dry run of our approach. Say this is our example. What did we do? We first turned the odds to double, right? 2, 10, 20 remains as it is, 3 becomes 6. Now we will perform our task in this one. Okay, so what is the minimum? It's 2. What is the maximum? It's 20. What is the deviation? 18. Is the maximum even? Yes. Half it. divided by 2, it is 10. But since it's a set, we have unique values, so this is what finally remains. Okay, now what is the minimum? 2. What is the maximum? 10. What is the difference? It's 8. Fine. What is the maximum? Is it even? Yes. Divide by 2, add the half. What is it? It's 5. Now again, what is the minimum? It's 2. What is the maximum? It's 6. Okay, what is the difference? It's 4. Now, is the maximum even? Yes, it's even. Remove it and add its half. Cool. Now again, what is the minimum? It's 2. What is the maximum? It's 5. What is the difference? It's 3. Okay. Is the maximum even? No. Maximum is not even. That's where we stop. Because as already said, if we alter the remaining elements, that's not going to help us. This is where we stop. Okay. So this is our minimized maximum deviation. Fine. Now what is the time complexity? Initially we are running a loop and adding all the elements to the set. That would take n into log n time. Adding takes a log n time. And here what we are doing, we are extracting the minimum and maximum, which takes big of 1 constant time. Then we are removing and adding elements to the set again. That takes log n time. But how many times are we doing this? See, what we are doing here exactly is we are turning the maximum element to minimum. That is, we are dividing the maximum element by 2 as long as we can. And to bring a element, even element to 0 by dividing it by 2 at each step takes a worst case time complexity of log 2 of say that number. So we are doing this much time, right? Say we are decreasing our max, so that will be a log of max time and into log of n, because at each step we are adding and removing. So this is our time complexity, and our space is definitely big of n. We are storing all the elements in the tree set initially, right? So yeah, this is pretty much the solution. It is a bit complex, I would say, definitely a hard one. So that's all. If you like this video, do hit the like button, share this video and subscribe to my channel if you haven't, and I will see you in the next video. Bye bye.